Alright, today we're going to go over a word problem. So, Jill has a bag of beans that weighs 2 356 thousandths pounds, and Jack has a bag of beans that weighs 3 7/10ths pounds. Estimate to the nearest whole number, tenth, hundredth, and thousandth. Well, we don't need to estimate to the nearest thousandth because we can just cross that one out because there is no digit after the thousandth, so this would technically be rounded to the nearest thousandth. Alright, so let's start. So it says estimate to the nearest whole number, tenth, hundredth, and thousandth. So the nearest whole number is basically estimating to the ones column. So the ones column is always the number to the left of the decimal. Okay? And when they say estimate to the nearest whole number, what they mean is they want you to round these numbers first to the nearest whole number and then add them together. Okay? So when we're rounding, we figure out what we're rounding to. We can underline it. Then we just hop over one digit to the right. Okay, so in the ones column for the nearest whole number, we're hopping over one digit to the right. And if that number, one digit to the right, is 0, 1, 2, 3, or 4, then that means the ones column stays the same. Okay, and if it is 5 through 9, that means it goes up 1. Okay, so up 1. So since this is a 3, that means that this stays the same. So this, rounded to the nearest whole number, 2 356 thousandths, is just 2. And here we have 3 7/10ths. So that would be between 5 and 9. So that means the 3 has to go up. So it would be 4. So if we are to estimate to the nearest whole number how much they have, I'm sorry, I guess this problem doesn't specify, but how much do they have in all? That's the question that they're asking. So 2 plus 4, so to the nearest whole number, I'll just put equals 6 pounds altogether. Okay? Now, when they're talking about estimating, you don't want to actually add these two numbers together, like 3 7/10ths plus 2 356 thousandths, and then you round that answer. That would be basically counterproductive. The whole point of estimating is to do it quicker and more efficiently. So if you get the exact answer, you might as well just stick with the exact answer. That's always going to be better than the estimated answer. Okay, so to the nearest tenth. Now, 3 7/10ths is already rounded to the nearest tenth, and it's already rounded to the nearest hundredth. Right, because this is, there's only zeros after this, basically, or you don't even have to write those. So it's already rounded to the nearest tenth. Now, we can round this to the nearest tenth. So you underline the number that you're rounding to, hop 1 over, and then it becomes to the 5, or I'm sorry, it goes to the hundredth, and that's a 5. So the 3 has to go 1 up, and then it becomes 2 4/10. Now, I could put zeros for these numbers, but when you add zeros at the end of a decimal, it doesn't change the value as long as there's only zeros. So to the tenth, to the nearest tenth, it would be 2.4, and this would be 3.7. So then we would just add those up. 4 plus 7 is 1. And you need to make sure when you're doing the standard algorithm, you line up the decimals and then just bring the decimal down. And then it's 1 plus 2 plus 3 equals 6. So to the nearest tenth is 6.1. And now let's see to the nearest hundredth if it gets a little more precise. Now, the smaller the digit is that you're rounding to, the more precise the answer is going to be. Basically, the closer to the real answer you're going to get, right? So, but that comes at a cost of, not making the problem very much easier. So, we're at 2 and 356 thousandths. We're going to go to the thousandth, to the hundredth, round to the hundredth. We're at the 5. We go over 1. To the 6, we know that that's 1 up, so it would be 2 and 3, 6. Okay, 2 and 3, 36 hundredths, and then plus, and as I said, 3 and 7/10 is already rounded to the tenths, to the hundredths, thousandths. So we just have to line up the decimal, and what we can do here is we can just add a 0 to just make it a little easier as a placeholder here, because adding a 0, 70 hundredths and 7/10 is the same value. So after the decimal place, you can just add zeros at the end of the number. And as long as there's not, another digit other than 0 over here, you could add an infinite amount of zeros and it does not change the value. So let's add this up. 6 plus 0 is 6. 3 plus 7 is 10. Carry the 1 from the 10. 1 plus 2 plus 3 equals 6. And always remember, this is not 606. Bring down the decimal. So that is rounded to the nearest hundredth. And let's just see exactly what it is, what the answer is. So you can see that as I move further along to the right, and the digits get smaller that we're rounding to, it becomes closer to the actual answer. So this is 6, 5, so this is the actual answer, 6 and 56 thousandths, which is actually only 4 thousandths away from rounding to the hundredths. It is, so 6 and 1/10. That would be about 44 thousandths away. Right? And rounding to the whole number gave us 6, which is obviously 56 thousandths away. So as you see, the further we go to the right, the less the digit is worth that we're rounding to or estimating to, the closer to the actual answer we get. Alright, so hopefully that